Thank you, Thea. And thanks for everybody for being out. Happy Monday. It's great for me to be able to speak to you today about how Spotify uses Kubeflow, specifically how we're using Kubeflow pipelines in our machine learning deployments. So first off, a little bit about me. My name is Josh Baer. I've been working as the machine learning platform product lead at Spotify for about two and a half years by now. I was asked to sort of build a team to solve our machine learning challenges, the challenges that we saw in common around our machine learning engineers after I spent some time migrating all our product, systems over to Google Cloud. So I've been working on that for about 2.5 years. We have 5 main engineering offices at Spotify in both the US and Europe. So our mission is really to consolidate a lot of what they're building and to unify their approach. So just to give you some idea of scale of Spotify, we're a music streaming service. Hopefully everybody knows. It's interesting. A few years ago when I used to give talks, not everybody knew what Spotify is. Now I think most people do. We launched in 2008. We have 230 million active users. Actually, I think we just announced today that we have 248 million active users. We have 50 million tracks, and we're launched in 79 countries. And I was actually talking this morning, and I realized it's probably relevant. We're almost exclusively on GCP, so we're a single cloud provider. We're not anymore on premise. We killed the last of our servers, I believe, at the beginning of 2018. And we have machine learning all over our product. I'm sure a lot of people that use Spotify are probably pretty familiar with Discover Weekly. The idea there is you get a personalized playlist that's brand new content every week delivered Monday morning. So if you commuted in today, hopefully you discovered some new music from that. But we also have it all over the application. So we have it in our homepage, recommending you new content when you go back there. We also have it in the search. And our earnings call was this morning, and one of the things I actually highlighted was how machine learning, we are doing some innovation in our onboarding process, and that's actually led to some pretty significant increases in the retention and the first played users. So we have machine learning all over our product. But historically, we've had a pretty big problem in introducing machine learning at Spotify, especially for teams that are new to machine learning. So here's a basic diagram that I use when I talk to teams around the machine learning journey for Spotify is bringing essentially their workloads out to production. And I'm going to be using it to discuss how Kubeflow fits in and where it makes an impact. So you probably are all seen a diagram that's pretty similar to this. You start out with the idea, identifying, is this a machine learning problem? Do I have the data to run something? Next up, you want to do some prototyping, understand which features are relevant to your model, onto the productionization when you have something that's worth actually going to production. So building a service, doing alerting, monitoring, all that stuff, setting up CI/CD if you have that, and on to the measurement experience and tweaking. So it's interesting. A lot of what I'm going to be talking about right here was covered pretty great in the opening keynote, so I don't have to talk too much. But we do internal surveys at Spotify to understand, how their journey is through this machine learning workflow and what their biggest problems are. And this is some of the data we've seen internally from Spotifyers. We realize we're actually not doing so great at all those phases that I talked about. So measured by the results of the survey that I've done, in the model prototyping phase, the majority of teams spend 2 to 6 weeks getting out an initial prototype, with about 28% of ML practitioners reporting that it takes up to a quarter or more just to get out an initial prototype. So the side effect that we saw out of that is that long time to MVP was actually causing teams that are new to deploying machine learning solutions for the problem. Their PMs were actually just killing the projects before they were even able to get to a place where they realized if this is worthwhile to pursue. It's not great if you want to grow machine learning across your company. And then in the next phase, the productionizing the solution, we've seen even worse results. So almost 1/3 of our ML practitioners, it takes them over a quarter just to get something working. So it was very typical for our teams at Spotify to have essentially an OKR just to bring their solution that they already had up and running out to production. So that's not a great state. And digging into these results a bit more, we discovered that what was happening is that each of those phases, they had their subcycles. So for example, in model type prototyping phase, you might develop, train, evaluate, and tweak many times before you get to the stage where it's actually an MVP. And if we converted those ML journeys into a timeline, we would see that those iteration of the individual phases were quite long, and they added up to slow overall development cycles. That's showing up in the results. So for example, it might take you 4 weeks to get to the initial sort of definition, then the prototype, and about 1 week or 2 weeks just to do subsequent iterations. And we realized that if we wanted to decrease the time it takes to bring an ML solution to production, we really have to narrow in on those subcycles and make them more efficient, those iteration loops. But those weren't the only challenges that we had at deploying machine learning at Spotify. We also needed to get a bunch of these other addressed. And I think Jeremy already highlighted a lot of these that we talk about that we saw as we were building out the platform. So we observed that teams found it very difficult to collaborate across their different teams. We have stories of going up to our search team, for example, and talking about, how do you track your machine learning deployments? How do you find out, what's going on across your teams? They just open up this massive spreadsheet with like all their different models that they were deploying, where it was stored in GCS, what the performance characteristics were. It wasn't a very scalable solution, and it wasn't very useful to other teams across the company. And we had teams using every possible ML framework and every possible ML solution to build their models. And that's not great for our ability to move machine learning engineers across teams or to maintain these systems over time, because you have to learn what they were using a year ago when they started the project, and it might not be what you're familiar with. And finally, we had those slow feedback loops, as you saw before. So the data analysis had a totally separate toolkit and totally separate experience from your model training and your model analysis. They all involve switching back and forth, and they all made it just very difficult to get machine learning up and running. So now for the hopeful part. About a year and a half ago, 2 years ago, we were talking about this problem, and of course we saw all the blogs that Uber was doing and Facebook, and I think that we're all mentioned this morning about building platforms. So at Spotify, of course, we said we want to build a platform too, and that's what we started to do. But then we had a chat with our Google Cloud partners, and we talked about our problems, and we told them that the solutions that they were building in GCP weren't really very relevant to our problems. And they mentioned that, hey, we're actually starting up a team that's going to be working on that problem. We have a lot of people that have built these solutions at other companies, and we're going to build something out, and we're going to open it, and it's going to fit you real right, well. So we were really hopeful about that. We decided to collaborate pretty closely with that team throughout 2018, follow very closely the path that they were building to make sure that we wouldn't end up in 2 years without anything. And then in November last year, the product was launched, and that was, of course, Kubeflow pipelines. And I should say another important piece of our stack is that about a year and a half ago, we had a pretty heavy Scala-based tool system for building out ML solutions. And we started to see a lot of blog posts about TensorFlow Extended, started talking to the team, and we realized that they were so far ahead of us with their thinking, and that they were just like the slowest thing for them was the ability to open source all these tools and to get it out there. And that if we bet on TFX and the TensorFlow ecosystem, we would end up further on down the road. And we also knew that TFX would align pretty closely with the Kubeflow pipelines, so sort of build that whole holistic platform experience. So early this year, we spun up a team to start working on this. We had some early developers try out Kubeflow platform. There were still some rough edges, in particular around bridging the gap between our Spotify ecosystem and the Kubeflow pipelines experience. So we spun up a team to build like thin layers to bridge those gaps. And here's a little picture of some of that team standing on the 69th floor of our downtown New York offices. And we ended up aligning on an approach where our infra team manages 3 Kubeflow clusters for our users. So this allows ML engineers to focus only on the ML bits, not about the Kubeflow. So eliminating the K from the experience is very much what we want to do internally at Spotify. This setup was useful. So we have the differences. We have the 3 clusters. We have development, production, test phase. But it's also pretty necessary because of our network setup on GCP. We have something that we use called shared VPC that allows us to connect all the projects and is very difficult for end users to maintain. So our infrastructure team takes care of it. So we have the test cluster that we use for our internal development, sort of the integration test when we want to upgrade TFX, or if we want to upgrade Kubeflow, then we'll test on our test cluster. Our development clusters for ad hoc jobs. And of course, we have a production cluster that we intend to be used for high SLO workloads. Right now, we're in the alpha phase, so we don't advocate for anybody to actually use that production cluster yet, but that's the intention. And we've also added a few features to our local Kubeflow deployment, some of which we hope to replace completely with the vanilla components, because a lot of this stuff is on the pipeline's roadmap. So these are, for example, caching. We use the metadata layer to quickly resume if you have failed workloads and you want to modify something. We use the central metadata tracker, which is incredibly useful for us for understanding what's going along across the organization, how people are doing development, how they're using Kubeflow. We built some command line tooling. So that allows you to both run from the command line, but also integrates pretty closely with our pre-existing orchestration tool, which is called Luigi. It allows you to just call out the command line and run a process so that you can orchestrate it with our in-house tools. We built the shared VPC integration, which is pretty important for us, being able to talk to different backend services. So if you want to deploy a model, or if you want to be able to read data from a different service, it has that integration. And we also built a lot of common TFX components. So I said we use TFX pretty heavily. That allows people to get up and running. So in August, we launched our internal version of Kubeflow, and we've already seen 15,000 runs on it, which is pretty impressive. And we've had, especially recently, a steady uptick in real sort of closer to production-looking jobs. So you might be thinking there, what's that blip in the middle, that's sort of the plateau? We actually discovered that we had a Renegade job that was running every 5 minutes. It was a sort of, fortunately, it was just a hello world spin up, spin out job. And because we're in the alpha phase, it took us a few weeks to discover that it was running and what it was. But the great news is that it was successfully running for over 3 weeks, and it sort of really load tested the infrastructure for reliability. Yeah, and so while it's in the early stages for Spotify still, and in this product, we're already seeing some pretty early returns as it relates to the development speed that I talked about at the beginning. So for one of our users, for example, he's a pretty mature machine learning engineer. He's got a lot of experience. The first iteration of a model that he was building, it was called an artist preference model. The idea is that we want to try to predict, if you've never heard of artists, what's the likelihood that you might be interested in listening to them. You might be interested in going to a concert, so we can recommend you some sort of content. So the first iteration of his model took over a month. That was all before Kubeflow, just getting to the initial version. And subsequent iterations were always also around that sort of month-long period. So when he started to use out Kubeflow in our tooling, his next iteration went down to a week. Now he's down to hours, building much more higher quality models than ever before. And it should be stressed that a lot of those improvements are from having all the different tools as part of his workload right there and able to be linked together. So one of the most crucial things that he does is he'll be able to run this thing and see pretty early on that his issue is not with the model, it's actually with the data. He's able to use TFDV and really dig into what's happening with his features and really iterate on that process a lot. So that faster iteration speed is absolutely critical as we build out new capabilities and even launch new lines of product that are powered by machine learning. And we saw that even more demonstrated last week. So we have this tradition at Spotify of doing a hack week every year. Engineers and people around the company stop everything they're doing and start out a new project. And in that week, we saw over 1,000 runs on a Kubeflow cluster. And that's mainly from brand new users that are trying this thing out for the first time. And the feedback that we got, that engineers were absolutely loving the close integration of all the data validation, training, and model analysis components. So it was really an impressive demonstration of how people are using this. So just to back up a little bit, so our timeline for how we started using Kubeflow pipelines and where we are today. So Kubeflow pipelines launched, it was I think November of 2018. January, we saw the first team starting to use it out and play around with it. In August of 2019, we launched our internal implementation of what we call a Spotify Kubeflow platform. So we're here right here, we have at least 10 models that have been built through Kubeflow pipelines that are being A/B tested in some sort of way in the product. Our intention is in around January, hopefully in Q1 of 2020, once we get some important features that we need deployed in Kubeflow pipelines, to actually launch a beta, which will open it up to the broader sense. And we're able actually to say this is a production grade tool. So our vision from Kubeflow pipelines, I'm sure probably everybody has seen this diagram before, this picture. If not, I'm sure it'll come up later on. It's from the Hidden Technical Debt Machine Learning Systems. The idea is essentially is that the ML code is actually a fairly small bit of the end-to-end workflow, and that all the other pieces are the bigger parts. And our vision for Kubeflow is that we want Kubeflow to cover a lot of those big pieces that users previously would have to deal with themselves. And we want to build components that fill in the gaps. So these common components that people can just plug and play into their workflows to fill in the gaps. Things like we're building out a feature store, or for model serving, them to be able to have easy access to that. And that'll create a world, hopefully, where it gets us to the point where the ML specific code is what our developers and our data sciences and our ML practitioners primarily focus on. And they're able to iterate really quickly and improve their results, and hopefully develop better recommendations for all you that are Spotify users. And the Kubeflow and the platform covers the rest. So that's our main vision. And I just want to sort of, before I close, do a big shout out. So I've been mainly observer for this community for most of the year, and I've been incredibly impressed by the level of expertise and the commitment that makes really this Kubeflow ecosystem thrive. And I'd say one of the reasons that Spotify is betting so big on Kubeflow in the community in the future is because of a lot of the people in this room that are pushing the product forward and developing a really great experience. So really, thanks a ton for that. And I hope by this time next year, seeing that slide, you'll see Spotify as one of the big contributors too. So that's the bulk of my talk. We'll be talking much more detail about our Kubeflow deployment at KubeCon next month. We have Keshi in the room and another engineer on my team. So if you're around for that, definitely check that out. And we're going to be doing a talk at TensorFlow World later this week. So thank you.